Hello everyone. Today we're going to look at uniform series, and this is where we have a constant payment every year for however many years that the problem states. If you look in the front of your book, you will see different cash flow diagrams for uniform series. You'll have the uniform series, which is constant, and then the final or future year, it is an F, and that F occurs at the same year as that last payment. Or you have the next one down, which is some present amount, and then the very next year, the next period, you will have your uniform series starting. Those are the two main cases. I'd like to present just a variation on this problem. And I will use, of course, the functional notation and not the formulas, because the formulas allow for a lot of error, potential error in calculation. The problem I would like to do is this one. We want to find an amount to invest today or now, so that in 10 years we will have $1,000 for 4 years. The missing information on here, I see, is that we don't have an interest rate. So let's give ourselves an interest rate of I equal to 8%. Okay, I did not put that in there. I equal to 8%. Okay, and that's the missing information. The first thing we do is we need to put in our givens, and our givens can always be presented as a cash flow diagram, which is very easy to do, givens. And I again am telling you that you need to do cash flow diagrams. They are required. They will give you the information that you need to solve the problem. So in this case, we have some time frame. At year 0, we have some amount we're going to invest. So the money is going away from us. We're putting it in the bank or something, so it's away from us. And we'll just draw it as a negative line. In year 10, we will have want to start taking money out, and we're going to do that for 4 years. Sometimes what we do, instead of drawing each of these arrows, sometimes we can draw the first one and the last one and just draw a straight line across, and that tells us that it's a uniform series. It's a constant amount each year. Okay. Let's put some labeling to this whole thing. We have some value of P. We don't know what it is. We want to find it. That is in year 0. We know that this all starts in year 10. And then we have 10, 11, 12, 13. So we're doing it up to year 13. Okay? And our interest rate is 8%. Okay? If you look at this, you will see we have this whole gap in the middle where we don't know or don't have any payments going on in the middle of there. How do we deal with that? Because this is not the same diagram as the one in the front of the book. It's a little bit different. The one in the front of the book always has this value of P to be right after our year, or right before our starting point of our uniform series. So what we need to do to be able to solve for P, though, is we need to have the money or the cash at the same time frame, at the same period. And it doesn't matter. It can be in year 0, it could be in year 9, it could be in year 13. It really doesn't matter. It could be in year 2 if you want, as long as the money is at the same location. Okay? Just for the sake of this problem, I'm going to bring it all to year 0. There is no right or wrong, or if that's not a better way or anything. The reason I'm going to do that is I also want to show you something else as I do this problem. So I want to bring all this money here to year 0. Okay? If I do that, I have a couple options. One is I could move first this money from year 10 to 13 using some present value amount, which would bring it to year 9. Or I could take it to some future value, which is out in year 13. I think for this particular one, to kind of make it a little more complicated and interesting, we're going to take it to year 9 instead. Okay? So let's do that using the formula that we know. Okay, so this is going to bring it to some value in year 9, and we're going to call that P sub 9, all right? That's what that value will be of that money. So if we try and solve for P sub 9, P sub 9 is equal to our A, sum A is our uniform series, and we're going to find P given an A at an interest rate and for some period of time. In this problem, we know our A, we didn't write that in here, we should have. In our givens, we know that this is equal to $1,000. Okay, so we do know that. $1,000 is what we want to take out for 4 years, and that is find a P given an A at an interest rate of 8% for 1, 2, 3, 4 years. 4 years. I could easily have again taken it to a future value, which would have put it at year 13. If I look in the back of the book, let's do that real quickly. In our Appendix C, in our tables, we will see for 4 years, we're finding a P given an A. We find that this value here is equal to 3.312. Okay, so now we know, oops, P sub 9, equals, I'm sorry, it will equal this 1,000 times 3.312, right? Which means that it equals 3,312. But that's not really what we're looking for. That just gives us the value here, right? We can now redraw our cash flow diagram. Let's do that. Let's draw a new cash flow diagram. All right? We would have a new cash flow diagram that looks like this. That didn't work very well, but that's all right. And we still don't. Let me redraw this so it looks a little neater. Sorry about that. There we go. We still have our P at year 0, which we don't know, but now we have some new value here, P9, right? So we still don't know P. Our interest rate is still the same. And then we know that this is year 9. And this P9 is, we can think of it also as an F, right? It's some future value. It's the same thing, which we have solved for, which is $3,312. Okay. Now we can solve for P using our single payment method. If we do that, we find P equals P9, which is also an F, which is find P given an F at 8% for 9 years. And here we will have P sub 9 is the same as F, is 3,312 times our value for P given F at 8 years. Find P given F for 9 years. I'm sorry, 8% for 9 years is 0.5002. Okay. Or P equals, let me use the calculator here real quickly, equals 3312 times 0.5002 equals about half, of course, which is $1,657. Okay, so there's our value for P. You can, if you want, you can write this all as one equation. Let's look at that. And this is kind of why I did it this way. We can write right from the beginning, from our initial, we should write solution here also. We could write from the very first cash flow diagram at the top. We could have written, once you get more comfortable, instead of doing this in 2 steps like this, you can write it all as one. And you can think of it, okay, this time I'm going to bring it to year 9 yet. I know I will have my $1,000 times P, find P given F, I'm sorry, not FA, right, it's an A at 8% for 4 years times P given an F, 8% for 9 years. Okay, if we look at this real quickly, and you notice they're multiplied each other, this value here is the same one as here, and it's multiplied because if we look, this value here is P9, which is here, which is here, which is that value there. And we'll end up with the same value. So you can multiply these and move them. This you can think of as our future value, F, or is equal to P9, right? P sub 9 should be an equal sign. Okay? So that's one way of doing it. I could have moved it, to confuse you a little bit more, I could have moved it all to year 13 also, right? And let's take a look at this same problem, and I'll write the same equation again, and you can think about it on your own. But I'm going to move all of the money to year 13 and then bring it back to year 0. So in that case, oops, let's write a little darker here. P equals 1,000 times, find F given an A at 8% for 4 years. So I'm moving all that money out to year 13. Out here is where I'm moving it. And now I need to bring it back to year 0. And I do that this time by find P given an F for, again, 8%, but for 13 years. All right, this 13 years, I need to bring it all the way back. So that's another way of doing this same problem, and you will get the same value. It may be off by a few dollars or something like that. That's just because of rounding errors or rounding in the table itself. Okay, so hopefully this explains uniform series a little bit. Be very careful when doing them. Also, always look at the cash flow diagrams in the beginning of the book and use your functional notation. If you have questions, again, email me with any questions that you may have. Have a great day.